Okay, let's get started with a lecture on section 3.3, the product and quotient rules. So a couple of rules that are going to be really important for our future calculation of derivatives. So I first want to cover the product rule in this video, and then in the following video I'll probably do the quotient rule, and in the third video I'll go through a few examples. So let's take a look at the product rule first. So the product rule says that if both f and g are differentiable, then the derivative of the product of f and g is f of x times the derivative of g of x plus g of x times the derivative of f of x. Another way we could write this is to say that the derivative of the product f and g is equal to f times g prime plus f prime times g prime, or f prime times g. So just to make it completely clear, here we have a product of functions, and if we're trying to take the derivative of that, then what we do is we take the first times the derivative of the second, plus the second times the derivative of the first. So this is what we call the product rule. Okay, let's go ahead and prove the product rule now. So what we're trying to find is d by dx of f of x g. This is a fairly long derivation, so I'm going to try to sort of conserve space, see how this goes. So the limit as h goes to 0 of, let's see, the function evaluated at x plus h, so it will be f of x plus h times g of x plus h minus the function evaluated at x, so here will be f of x times g of x all over h, just the definition of the derivative. So here's what's going to happen. There's going to be a fairly non-standard algebraic move here. I'm going to add and subtract a piece that I need. So the idea is to add and subtract this piece. It'll be minus f of x plus h times g of x plus f of x plus h times g of x. I know that seems like a very strange thing to do, but just keep in mind that what I've added in and subtracted, this piece right here, that's just equal to 0, right? So we haven't changed the nature of what the original derivative expression is. We've just added and subtracted the same term on the numerator. But what's important to see now is that we can factor out some things. In the first one, we can factor out f of x plus h, and what's left inside is g of x plus h minus g of x. In the second two terms, I can factor out, let's see, a g of x. And what's left inside is then going to be f of x plus h minus f of x. Okay, well, let's see how this goes. We could split up the sum that's on top of the fraction, and we could get it in this form. I hope that makes sense. So all I've done is split up the fraction with the addition in between, and then rewritten, I guess, the left and the right-hand terms. So now I'm going to go ahead and distribute the limit.
Check, check. 1, 2, 3, 4. Check, check. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2.
Sorry about that. I'm getting ready here to be in a session at my meeting. Let's see. So all he did there was then just give the limit to each of the two terms in the addition, and then each of the two terms in the respective products. And I think now we can kind of see it popping out. This thing, as h goes to 0, f of x plus h is going to go to just f of x. This, as h goes to 0, what we see here is just the definition of the derivative of g of x. So this would be times g prime of x. And then as h goes to 0, well, g of x isn't affected by h, so we just get a g of x here. And as h goes to 0, my right-hand term, of course, is the derivative function itself. So we end up with exactly what we were supposed to get. The first times the derivative of the second, plus the second times the derivative of the first. And that's the proof. So the proof is fairly involved, and it requires we sort of invent the term that we need, basically, and add it in and subtract it. So the real genius move is the piece in red. But in the end, of course, it works out, and we do get what's called the product rule. All right, in the next video, I'll take a look at the quotient rule.